Today we are going to talk about debugging with GDB. Yes, so if you haven't installed GDB on your environment, you can install it right from their website. I'll provide a link for you guys to install it. But then if you're using Linux environment or you are using a virtual machine, a Linux virtual machine like I'm using WSL, you can install it from the terminal using this command. So you can use this command to install it. I've already installed it and I don't even have an internet connection right now. So otherwise you can check from the link to find out from GNU website and see if you can follow the instructions there and install it. Now after installing it, you have to install an extension. So you go to your extension bar and then search for C++ extension. I have mine already installed. This. So you can look for this. This allows you to debug and also browse and provides you with IntelliSense, suggest code for you and other things. So you can find out, but then this the entire extension pack, I think, which I also have downloaded it and installed it on my WSL. Alright. Now once you have all this in place, we can start with debugging. So in this code, I have a code that has some bug in it. So you can see in here, I have a bug function. So this particular line has an error. So at a point in time, if you look at this, I is going to be equal to the size of the array, right? And we know the array, when you try to index the array size, you are going to get an index error. So mostly this zero is, in this particular case, it is straightforward, and I've even shown you where the error is. But then when you are writing many lines of code, this becomes a problem to spot. Sometimes it's difficult to find out where your error is. Then, so a debugger allows us to fish this out, bug this one out. So let's talk about our code and how we are going to use the debugger to spot this code. So once you have your C++ extension bar and you go to this bar, so you can see there on your taskbar, one of your taskbar, you'll find this symbol, like you have a literal bag on it, and then it's called run in debug. So you can use this run in debug and then continue your debugging. So also sometimes, in my case, I only have just a file, but sometimes you can have multiple files. So clicking on this link will provide you with help for you to know how to configure your C++ project so that you can debug multiple files. But mostly for a single file, like in my case, it would automatically create a debug file for you. So after clicking run in debug, you are going to see C++, GCC build and debug. You are going to see these options. Now on my class, I'm going to use this, right? I'm going to use the first one. And then once I click on it, yes, so you can see it is compiling and then debugging. Now you can see that nothing happened, right? Something happened, but then we didn't really get what we wanted to do. This is because we didn't create any breakpoints. Now, what is a breakpoint? So a breakpoint is just in your code. You see, the code runs sequentially from top to down, unless it meets a jump statement, then it will go back and then run back again. Do you understand? So a breakpoint is just, let's say, a point that you have to specify that when your program run and then reaches that point, it should stop. Is that okay? And as we already know, every C program starts in the main function. So it will start running from here and then it round this line, round this one, round to round and then call the buggy function. Now imagine we run our code normally in the terminal and then we are getting some is 15. But then, as I said, this particular area is giving us an error that we couldn't spot. Let me see if we can get the error from the terminal. So you can use the command gcc test. So let me provide one name, then let's see if we can get if it will point out this error for us. So mm, let's call this app and then test. Okay, so we have one dot c. Right. So when I list it, let me remove this one. This is not necessary. So now when I list it, and then let me list everything here. Now when I list it, you can see this is the app, the executable that I generated from this program. So after compiling and linking everything, this is what I have. I have the app integer. Now we try to add one to, we are supposed to get something like a 15. I think so. But then in our case, that's not what we are getting. Right. When we run this, you can see we are getting some gibberish value. Sum is equal to this. So we want to know where the problem is. What is causing the problem? Is that okay? So that's what we are going to do today. Yeah, so we have array. So we don't know where the error is coming from. So what we can do is that we can set a breakpoint anywhere before, let's say, since we are not so sure about it. Now, how we set breakpoint in VS Code is you hover around this and then you see some red dots over there and you click it, it will be highlighted. Now, inside here, when you come here, let me see if I can make this one, I can extend this to make it bigger. Unfortunately, it's like I can't. So what happens is that, you see, once you create a breakpoint, it shows up in here. We have a breakpoint in here. Now, what it means is that once I start my execution, the execution will hang at this point. Let's see how that will work. Run. Yes. So you've seen that the line that I set the breakpoint at, that's the first breakpoint that we hit. And that line is highlighted. Can you guys see? Yes. So since this is now, it's like the execution is at this place, and at this place you can view the content of the local variables that have been declared. As at this point, we only have one variable declared, which is the array, and you can see it as a local variable inside main. Do you guys see it? So when I open it, you can see array is now 1 8 negative 1 8 negative 8 1 1 1 and so forth, right? Yes. So we can go ahead and then execute this like that. So after breaking at this point, we can either do one of these things. We can stop the entire debug session, restart it, or we can step into a function like a malloc. But then malloc, we normally step into our own function that we wrote, because malloc is in the standard library, which has been tested over to make sure it contains no bugs. So it is less likely that you find your bug inside the malloc. So you wouldn't want to step into this function. But then what you might want to do, what you might want to do, what you might want to do is yeah, so what we might want to do is that maybe I'm coming. So what we might want to do is we can continue. When you continue, it means that we go over, like we continue our execution without breaking or stopping. But then what we normally would want to use is step over, so that we step over this execution and go to the next line. Yes. So step into a step out will be used later. So now let's step over and then get to the next line of instruction. So after getting over this, you see we get straight to this instruction. Now there's a condition. We are checking if this condition is true. And then it's a for loop with this condition. I mean with this the actual condition is here. So we initialize and then compare I. If it is less than 5, we execute this. Now I was initially 0. Okay, in here I is 327. But then after stepping over again, you can see now I is 0. So after executing this entire instruction, you can see that I is 0, and then we can continue. So in the next case, we are going to compare I again. Now, while we do this, you see our array. I think I should have used an array instead. So we want to see the content of the whole thing. I'll show you another way of doing this so that you can view the content of the entire array. So let me use that and then we will restart our debug session. So instead of using a dynamic array, let's use static one. Right, so we are going to use an array of integer of size 5. So let's say we have 5 over here. And then this becomes, so let's initialize the array to 0. Okay. So let's start our debug section and then see what happens. Exactly. So this is what I wanted you to see. Now, when we are starting our execution, you can see I is 0, right? So we initialize I to 0, and then we compare is I less than 5. Obviously, I is less than 5. So we step over. When we step over, we get into the condition. So the condition is satisfied. Now we execute what is inside here. Now we are saying that now initially you can see the element of the array is initialized to 0 from here. Now after doing this, what happens is that you have your 0 being equal, we are assigning index 0 to I plus 1. So let's execute this instruction and see what will happen. After executing it, you can see the first element in the array has been updated to 1. And then we can keep on doing it. Then you can see the next element has been updated to 2. So you can watch here and then see what is happening while we execute each line. So after everything, before going into this function, you can see that we are going to have the contents of the array to be this. So what you want to do is that you want to add 1 to 2, which will be 3 plus 3, 6 plus 4, 10, and then plus 5, 15. So we are going to expect that baggy function is going to add everything and then give us 15. But as we saw previously, that didn't happen. So we would like to step into that function and find out how it also performs. So this is where you can use. So with your functions that you wrote, you can step into them when you read that line. So you're about to execute this. We can step over so that we just get out of it, but we can also step into it. Now, since we want to find out what is going on inside baggy function, we are going to step into it. So let's step into it and see what happens. All right. Now, when we step into this has a sum variable, integer variable, initialized to 0 as shown over here. It's a local variable. And now we have an array, right, which we pass to function. So okay. Now previously, if you took notice of our previous function, you could see that the address of the array is this, right? So that's the array that we are passing to the function. Now inside we compare the similar thing that we did earlier on.
we initialize I to 0, and then we have size to 5. Now you see the size of the array is 5, but then we are looping through it size plus 1 times. Do you get it? So it means that we are going to get an out of range index error. In Python, for instance, the interpreter will raise this as an error. But then as we saw earlier on, C doesn't do that. So it means finding those bugs is quite difficult sometimes. Because you won't be getting what you are expecting, but then the compiler will also won't also flag this as an error. So now let's loop over it and see. So you are saying sum is equal to array I. Now let's see if we can have array. Okay, we don't have array I over here. But then basically we are indexing the array from 1. If you remember earlier on, we are taking the first element, which is 1, because that's when I is 0. I is 0, so this will be array 0. And then we sum it. Now watch what happens to the sum. Now you see sum is now 1. So we are going to add the next element, which is 2. 2 plus 1, that will be 3. So we see that sum is 3. So you can watch what is going on here, right? Now we go ahead. Now I is 2, and then we update. We see 3 plus, the next element is 3, so 6. Yes, so plus 4, the next element, that should give us 10. So you see we have a 10 over there. And then we can add again the next element in the array, which is 5. This should give us 15. Yes. So now the I is 4. So we can only index from 0 to 4. But then the array doesn't stop because we are iterating from 0 to size plus 1, which is from 0 to 6 instead of from 0 to 5. Now let's see what happens to the array. Right. So we have this. Now look at what happens over here. So it means that the element as at array size is some gibberish, right? That's why we are getting that now. So now we can see that we iterate more than we are supposed to. So we can fix the error by, let's say, making this one size, and then this should give us the proper output that we are expecting. So you can restart it to debug and then start. Let's say it's a breakpoint at sum, so that now we continue. Now we are breaking at sum. Is that okay? Now when I get to the sum, you can now do it all over again. You see what we are going to get. Now when I get to 4, you see that we will run the now I is 4, right? You run, yes. So now since I is 4, we are going to increment it, and then going to be 5, and we'll compare it to the size. The size was 5, as we can see, it's 5 over here. So now after comparing 5 is not less than 5. So you won't execute this any longer. Then we go to the next instruction, which is the sum. Is that okay? Yes, so after executing this, we can execute that, and you can see that our sum is already output to a 15. Now you can go ahead. Now an error also occurred. Why? Okay, so this error is because initially we were using a dynamic array. Yes, so dynamic array is just an array that you manually allocate memory for. So you have to manually free it. But now I'm using a static array, which doesn't need to be freed. Right? That's the exception that I'm getting here. So you can comment this one out. But if you are using the dynamic array, as I was using earlier on, then you must free the array because you allocated that for your program. All right, I think that is it. That is all about breakpoints debugging using VS Code. Now, as you might have seen, so we have this error shown here. So if you want to verify if rectify it, you can run it once more and then continue, 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 continue. You see no more errors flagged, so we didn't get any errors. So it means that everything is working as it's supposed to. Now, usually I don't use This way, I don't debug this way because it doesn't give you the freedom. And sometimes when you have multiple files, you have to create a configuring file. As you can see here, you have to create your own launch.json, JSON file. Well, I usually don't like that much of work, so I use the GDB from the terminal, which is also very effective once you know the commands. So what I do is that when you are compiling using this one, I'll compile with this flag. So the hyphen war hyphen w extra our flags. So I add this flag, which is a debug symbol flag. So I'm trying to tell the compiler that I want the compiler to add a debug info to the to the executable that it will create, right? Now you can look at this. Let's look at something. Now if I run this program without the debug symbol and then I list all this, look at the size of this executable. Take note of the size of the executable. Now if I run it with G, the debug symbol, let's see what it will also give. Now let's compare the sizes. Now you can see the size of this one is way bigger than the size of this. Right. Yes. So this one has extra information for debugging purposes, which are debug info. We call it debug info. So it has debug info for you to be able to debug your programs. Now, when you are creating a program, you don't want to add the debug symbols so that someone can easily reverse engineer your product. Yeah, so basically what we are doing helps in reverse engineering. It's okay. Now, if you are releasing a product to the market, you wouldn't want to add the debug info to make it easier for people to reverse engineer your app. And also, it will also make the debug info makes the binary larger. So you can see this one has thousand, there's 16,000 size, and this has 17,000 bytes. So okay, the second one, which is the one with the debug info, means that there is extra information added down here of source code. So yes, if you are testing your program, writing a program, it is always advisable to add this flag so that when you are debugging, it becomes easy for you. Okay, so when I was using the running debug, the, the extension does that automatically for me. It runs the program with the debug symbols. So it does that for me. So what I'm doing now is I'm manually doing this. And then once I create my binary, so let me remove this binary which was created by the what I did earlier on. So now when I create a binary, now I have a binary rate debug info. All that I need to do is launch my GDB with start debug the app. Okay. So you do this GDB and then run it with the app, and then that should. Now, as you can see over here, reading symbol from. So the debug information that you added to the binary app is read by GDB to help you debug or reverse engineer your products. So what you can do here is that now the GDB from the terminal doesn't work with this breakpoint. So if you want to set a breakpoint, what you need to do is to do break. Then you specify the file that you want to set the breakpoint in. So in this case, we have one test. So this should be it. Yes. So you specify the name of the file and then the line that you want to set the breakpoint to. So in here, let's say you want to set a breakpoint at sum. Is that okay? We want to set breakpoint at sum. Now you set it at 8. Is that okay? That's the line 8, the same thing. So we set it in file, this file.c and then 8. And then you have your breakpoint. Now from here, you can see we've successfully set a breakpoint at line 8 in file test.c. After setting this breakpoint, now we can run. So we have a command called run. That's when you run it with the inside the GDB. That should work. I think it's the same thing on Windows. I'm not really sure, but then I think you can also launch GDB from the terminal on Windows terminal, maybe PowerShell, and then you can use these commands to step through your code. Now, after running this program, the program will pause. It will break at where I set my breakpoint. Now these red lines, it doesn't know these red lines. These are for the extensions. But then from the terminal, don't do that. But then we set a breakpoint already, so we can run our application. Now, when you run, there is something that I need to configure. I have to do this. I don't have internet connection. I'll do it later, and then I'll say yes, and then I run it. Now you can see when I was running it, the GDB stops at where I set my breakpoint. It's 8. Do you guys see it? 8. Now when I'm here, the options that we have here, continue, step into, and all those things, we also have the same thing over here, right? So if you want to step over, we use next. So this will send you to the next instruction, which is a comparison. So now we are going to compare and see. Now we can print the local variable and see. So initially, call this function with this array, which has this address. We can print the array to find out what is in the array. I think I'll do that right away. And then size is also 5. So we pass this to the function, bag function. It is showing in the debug. And then we can print the array. How do we print the array? You can print it using this. Now this only prints the first element. But then if you want to print all the 5 elements, you can use this, print the 5 elements. So this is showing us the contents of the array. You can see the array contains 1, 2, 3, 4, 5. Now imagine if I do it 6, it will show me the next. So you remember we are getting an error. So this is a Debugging value. We didn't set this value. Now the reason why C gives you that freedom, so you have to check your boundaries and know the size of your array so that you don't write out of boundary. Now this poses a serious security issue if you don't manage them well. People can use that to hack your system, if I should say. Yes, so you need to carefully handle it. Now, when I come here and then I get my array, I know my size is 5. Now, what I do is that I can also print sum to see what is in sum. So let's see what is in sum. So sum is 1 because we executed this, the first one, when we executed this, sum was 0 was added to 1 and then stored in sum. Now we are going to compare I. Let's see what I is. When print I, you can see I is also 0. So of course, 0 is less than 5. So we'll go to the next instruction and run again. Right. Now let's print I and see what's in I. You can see I is now 1. So okay. Now we are going to execute this one, another sum, and after you can print what sum is now. Print sum, and then you see sum is now 3. So we added 1 to the next element, which was 2. So 1 to 2 will give us 3. So you keep on doing this if you like. You can continue so that it will just continue your program. If you use continue, it will run, and then when it meets the next breakpoint, it stops. Now when you continue, we are supposed to break at 8 again because it's a loop. So we keep on running it. You understand? We see we are still at the 8. All right, that's continuing. So we do that next until we are done. So now we execute the last, and now we have sum is equal to 15. So this is how you step through your code to make analysis. After this function, you see that we return to the main function, which is this line, and we are about to execute this. Then now when you print array, it's not going to give you, okay, we already have the array in the local variable, so yes. But then let's say if you print sum, let's see, print sum shouldn't give us. So yes, there is no sum in the context error because in here we don't have sum in here. That's why, and now we are in the context of main. So that's the reason why when we print sum, we don't get anything. Okay, I hope what I've taught so far is clear enough. On future videos, I'll try and then do it for multiple files, but then I think for now, this should help you debug. For multiple files, I'll advise you use a terminal because it helps you to set breakpoint in whichever file that you want to set the breakpoint in, and then when you run the code, it will break at that point. You can also use the GUI parts, the extensions to do it, but then with that, you need to learn how to configure a C++ file so that it can effectively do that for you. But as you can see, this gives us a freedom. You realize when we pass the function, when we were using this part, and we pass the function, we pass the array into a function, we couldn't see the content of the array inside the buggy function, if you remember. But from here, all that you need to do is to print the array. You print the array, right? Print the array, and then you have all the content of the array like that. All right. So basically, I think that's all. And then when you want to execute a shell, like a normal, like for instance, list, yes, you can use shell list. And then if you want to clear the console, you use shell clear and so forth. There are other more interesting things in the executable. Now imagine you have an arbitrary executable. You don't know. In this case, we had the source code, but then we don't know the source code, and we want to find out what is going on in the program. Mostly, you can use disassemble to disassemble it, and then let's say we know buggy function, and then let's say disassemble main. Let me see. Let me bring new file. Oh, I said disassemble. It's disassemble. Okay, so I think that's my it's disassemble. So disassemble. Yes. Now when you use disassemble, this is what happens. Right. You have the source code. Right. Now this is what is happening. This is this is assembler for the 86 architecture, right? X86 architecture. Yeah, so it's a complex set architecture. And then you can see the instructions there. We have all these instructions has meaning. But I'm not really a low level programmer for now. So I can't really tell you a lot about this. But then yes, this is what people use to reverse engineer executables. So once you have an executable, you can use this to go through the assembler and see whatever else. And you can see this was our return. This is where we end our program. And then you can see this, we made a function call to the buggy function on this line. Now, what you see here, all these things that you see as engineer. Right, that's about debugging. There are a lot more important functions or important uses of debugging, but I think I've taken you through the basic use of debugger. Thank you. Bye bye.